Hey everybody, here's your review for the CBA tomorrow. We went over this in class. Pre-AP classes, got through the whole thing. First period and second period, got through all but just a few questions. I'm gonna show all of it, but pause the video for what you need. I'm not gonna go over every question. I'm gonna let you look at the work that I show on each one. So anyway, here's number one. All you need to know is where the dependent quantities are, where the independent quantities are, and then you can answer those questions. If you know our little dry mix strategy, you'll know what to do. 2, know that left is independent and right is dependent always. So you've got dependent quantities over here, independent quantities over here. Number 3, trying to find the relationship in that table. Obviously you're subtracting 6. So we need to take x values minus 6. X values minus 6. Give us our y values. This would be the trick right here, would be to switch the variables on you. It's not y values minus 6. It is x values minus 6, so be careful. All right. Number 4, another relationship in the table. You're dividing by 18. But I need you to watch out for something here. You are dividing by 18 in every one of these. And the answer choices I gave you, there's only one that shows dividing by 18. What I want you to watch out for is it could look like this. It could look like t equals s divided by 18 this way. Remember, fractions are division. But this is what I really want you to watch out for. You got to remember that t equals 1/8 times s. That's the same thing as doing s divided by 18, because multiplying by a reciprocal is the same thing as dividing. So for example, this is dividing by 18. We talked about this in class a little bit. 18 is just 18 over 1. So if you divide s divided by 18 over 1, that's the same thing as s times 1 over 18, because multiplying by a reciprocal is the same thing as dividing. Really need you to watch out for that. If that's an answer choice, then it would be okay to pick this, because this and this and this are the same thing. So be careful. Another relationship in the table, multiplicative times $1.98. Remember, G values times $1.98. So you want this one, G values times $1.98 equals C. All right. Moving on here, more relationships in tables. You're multiplying by 4. So this is a not question. Watch out for these. This table represents an additive relationship. Not true, okay? Not true. The rest of these are all true. We were looking for one that's not true. All right, just know on a horizontal table, independent on top, dependent on bottom. Easy to catch. Big giant question here. Takes up half of the page. All you got to do is match one of the tables below to the graph. Okay, so when it says x is 2.5, y is 5, come up here and take 2.5 and see if it matches up with 5. Give yourself a little check mark. Yes, it matches. Yes, it matches. And finally, you see here, no, it doesn't. Same thing with this one. Yes, it matches. No, it doesn't. Yes, it matches. Yes, no, it doesn't. Okay, check every single one in the table to make sure that they match up where they're supposed to. All right, not a hard question. It just takes a while. All right, more relationships in tables, except just a word problem. You kind of have to build the table for yourself. You're multiplying by $5.60. N values times 560. So 5.6 is the same thing as 5.60. N values times 5.6. You're not subtracting, you're not adding, you're not dividing. Here's the trick. This is also multiplication, but they switch the variables on you. Make sure you are multiplying by the right variable to get it right. Equivalent expressions, you just have to simplify them and say, are they equal? Obviously, those two are not. These two are not. Once you simplify them, These two are not. You can't use the commutative property with division or subtraction. That's what they tried to do here. And these last two, when you simplify them, you can use the commutative property with multiplication or with addition. So y times 2 is the same thing as 2 times y. So these are the same on both sides. Prime factorization, just factor the number. And the number is 50, factor it, write down what the prime factorization is, and what's missing. Well, 5 squared is missing, 5 squared, okay? We've done a lot of practice on that in class. All right, order of operations here. Add what's in the parentheses before you do the multiplication. So subtract what's in the parentheses before you do the multiplication. I simplified this one step and found one that was equivalent. Didn't even have to solve it all the way. All right, 13, prime factorization. Make a factor tree, see what you get, match it up with an answer choice. Also, huge clue, 220 is not prime, 55 is not prime, 4 is not prime. Prime factorization, all the bases have to be prime. All right, equivalence. All right, what fraction represents 16%? 16 over 100, find an equivalent fraction. 16 over 100 is not one of these choices, but 8 over 50 is equal to it, so it is. You can also see how I was checking to see if the others were equal there. All right, number 15 wants to know about the area that's not shaded. So 18 out of a total of 40. Simplify your fraction until you get a denominator of 100. So I divided it by 2 to get a denominator of 20. Multiplied that times 5 to get 100. Same thing as to my numerator. Divide by 2, multiply by 5. 45 out of 100 is 45%. You could also do 18 divided by 40, but long division is going to give us problems, so I would stick with equivalent fractions. All right, when asked about their favorite foods, there's all these different options that kids chose, but it only asked you about those who chose tacos. 20%, which one of these is equivalent to 20%? Hopefully you can kind of look at what my work is there, figure out what I did. I'm talking too much like I normally do. Try to keep this video to less than 10 minutes. Let's see here, number 17, 6 out of 20 students in math class have blue jeans. What percent have blue jeans on? So take 6 out of 20 and turn it into a percent, meaning you need a denominator of 100. So I multiplied the numerator and the denominator by 5 to get 30 out of 100, which is 30%. You can take your 6 and divide it by 20, which is going to end up making it a decimal, and then you have to change that decimal into a percent. So this strategy is a little longer. I like equivalent fractions a little better there. 18, multi-step problem. I'm not going to talk a whole lot about this because we did talk about it in class. So if you need help on this, go back and look at each step that I did to see how I got to 20%. 19, I used this graph to, this strip diagram to fill it in. If you know where 100% is, you know where 50 is, you know where 25 and 75 are, you know what half of $80 is, you can kind of fill it in from there to get what you need. You could use the 10% rule, move the decimal once to the left to find 10%. 10% plus 10% is 20%. If 8 plus 8 is 16, so there's another way to solve that. And the last one was take this percent and change it to a decimal. Use that D to P strategy. Actually, we're starting with the percent, so we're actually going the other way, P to D. Move that decimal twice. Now it's 3.2 or 3.20. That should help you guys. Pause this video, look at each question that you are not really sure about, and definitely look at the ones that if you did not get to them in class, look at the ones that you did not get to so you know what to do, and good luck tomorrow on the CBA.